everybody, let's spend a little bit of time going over how to find the formulas from coordination compounds. This is problem set 5-2 in the Ultimate Chemical Equations Handbook. And I have included a table that's got names and formulas of some of the more common ligands. It may look different than the one that's in the book or whatever, however you have whatever you have, but it's got all the same information. So let's get started naming some of these things. Okay, so let's look at number 1. Okay, and so what we're going to do is we're going to name this thing just like we're going to come up with the formula just like we would for ionic compounds, going back to things like magnesium chloride. Okay, and then we have to know what the charges are so that we can know that there's supposed to be 2 there. Okay, and we name the half and the half, and then we can come up with the formula. Okay, so it's kind of the way that I like to do it, is to name the halves and then put them together. Not name the halves, but find the formula of the halves. And so that's what this space does. It really gives us the halves that we're dealing with. Okay, and so let's see. So let me erase some of this doodle here. I always encourage people to pause the video and try to do it yourself before you see how I'm doing it, or at least on some of these. There's plenty. We're going to go over 5 of these things here. Okay, so potassium is K. Okay, now in green, I'm going to just put the charge of potassium here, and I'm not going to include that in my final write of the answer when I write the answer out, but I'm going to put it there because I need it there to find out how many of them there are when we do the final write of the answer. Now, this is the compound, but since I name it, start backwards when I name it. Okay, this is backwards. Hexa is going to be 6, cyano is cyanides, CNs, and ferrate is 3. Or ferrate is iron, Fe. Okay, now what does this mean? Let's figure out charges. Okay, iron is 3 plus, cyano is 1 minus, and there's 6 of them, so that's 6 minus. So this whole thing here is 3 minus. Okay, what we know is this is a compound, and that the green charges all have to equal 0. So we're going to need some of these to cancel out this. So how many pluses do we need to cancel out the 3 minuses? We need 3. So if I'm ever asking you to do this, what I would ask you to do is just rewrite the compound nice and neat without any charges and with the appropriate brackets and parentheses in there. So that's potassium hexacyanoferrate 3. Okay. So sodium hexafluoroaluminate. Okay, notice there's no charge here. That's because aluminum is a main group element and it always has a 3 plus charge. More on that in a minute. So let's do our work. So there's sodium, and sodium is always a plus charge. Okay, so I'm going to write that over here. Okay, again, that's just kind of a notation, so I know how many in the end that I can when it has to balance out to equal 0. Okay, so hexafluoroaluminate. Again, it's named backwards, so I'm going to start here and I'm going to write it from the backside. So hexa 6, fluoro is F, and then illuminate is this. Okay, now notice there's no parentheses in here. When you have just the element, just one element, you don't put parentheses around it. Up here we did because it's 2 elements in that ligand. Okay, so now I'm going to switch to green. Okay, so now fluorine is a minus. Okay, you can see it over here. Fluoro, see the minus. It's hard to see. It'll be a little easier to see on your own copy. Excuse me. And then aluminum is always a 3 plus. That's why there's no 3 here, because it's from the department of the redundancy department in order to put it there. If aluminum is always 3 plus, you don't ever need to write it. Okay. Let's so now what I know is that this all has to add up to 0. There's 6 of these, so this is 6 minus. So the only thing we can change is the quantity of this and the quantity of that. Okay, well this ion here has a total of 3 minus. There's 6, 1, so that's 6 minus, 3 plus, 3 minus. Okay, so that's a 3 minus. So how do I get those to cancel out? I'm going to put 3 sodiums there. So this is going to be Na3, because there's 3. And then we put a bracket, Al, no parenthesis, F6, end bracket. Okay? Okay, so number 3. This is the diamine silver ion. Okay, so quick question, positive or negative ion? It's the positive ion because we didn't have to manipulate the name anyway, okay? The name, excuse me, the name, if it were the negative ion, this would be argentate, okay? We use the Latin name when it's the negative, okay? But since it's just silver, now we're going to, since it's the actual American name, we know it's the positive side. So again, since this is just the ion, it's not the whole compound, we're going to start backwards. Diamine is NH3, and that's more than one compound, so we do that. And then silver, and then we put it in brackets, and now we need to figure out charges. Okay, so I'll pull up my green. Okay, so this is 0. Silver is always +1. So this guy is a +1 charge. So now I'm going to rewrite this. Put my square brackets, NH3, 2, and we're going to put a +1 there. Perfect. Okay. Okay, tetraamine zinc nitrate. Okay, so we'll go backwards. Okay, we like to go, so this is read forwards, we're going to write it backwards. So tetraamine, NH3, zinc, Zn, okay, and then nitrate, NO3. Now, notice again, there's no number in parentheses here. That's because, like silver's always a +1, zinc is always a +2. Okay, so now this means that this guy here is a 2 plus charge. Zinc is 2 plus, amine is 0, so 4, 0. So that means that 2 plus and then 0. So that means the overall charge here is that. Now nitrate is something that you should have in mind from your naming kind of binary and polyatomic ion compounds, kind of like introchem stuff. Okay, and so nitrate is one of those polyatomic ions, and the charge on nitrate is 1 minus. Well, how are we going to get 2 plus and 1 minus to work out? Well, that means we need 2 of these things. So when we rewrite this, this is going to be zinc, amine, and why do we put parentheses? Because it's multiple elements in that one ligand, and then bracket, and then we're going to go NO3, and then there's 2 of them. Okay? Yeah, good. Okay, now the last one. Sodium tetrahydroxo chromate 3. Okay, so the parts here. So this is sodium, that's Na, and just like I did up above, I'm going to put the plus there because this is what we're going to use to balance out the charge on the anion side. And again, it's written forwards. I'm going to write it back. It's named forwards. I'm going to write it backwards. I'm going to name it. I'm going to write the symbols backwards. So tetra is 4. And then hydroxo, if you're using my table, hydroxo is OH minus, okay? So this is, I don't know why I have the green pen. Don't want to confuse anybody. So tetra, and then hydroxo is OH And then chromate comes from the chromium, and that's 3 minus. Okay, now this is all one ion. Charges, let's see, hydroxide, not hydroxide, hydroxo. Okay, that's a 1 minus. There's 4 of them, so this is a 4 minus. But chromium here is a 3 plus. So 3 plus and 4 minus equals, for this ion, a 1 minus. Well, sodium is a 1 plus, this is a 1 minus. So that is a neutral with just one of these and one of those. So this is going to be sodium, and when it's a 1 there, we don't write it. So it's sodium, bracket, because this is where the ion starts, the complex metal ion, OH4, and bracket. Okay, so that is questions 1 through 5 on problem set 5-2 from the Ultimate Chemical Equations Handbook. I hope that helps, and have a great day.